And welcome to all for this internship program of VPM's Polytechnic Thane. Before I begin and introduce the speaker, let me explain the house rules for all the participants. At the end of every day's talk, there will be a question answer session. Participants can send their questions in the chat box. Our team is monitoring chat box for your communication. At the end of every session, the quiz link will be provided on your mobile and mail. You have to submit the quiz every day, but we are keeping the link open till the last day. To get the certificates at the end of webinar program, your daily attendance is mandatory. And the last and interesting point is about rewards. Every morning, the star performer of the session will be declared. Our generous entrepreneur alumni have planned for lucky draw and Amazon gift pack for you, provided you attend the entire sessions. And most important is, please keep yourself on mute. So stay tuned and be the winner. Taking the webinar series forward, we are joined by Mr. Devendra Pradhan today. I am happy to introduce the speaker, Mr. Devendra Pradhan. He has done diploma in instrumentation and passed in the year 1989 from VPM's Polytechnic Thane. He joined Albright Morarji Pandit Limited Ambernath in 1989 and then Messrs. Nishko Instruments Private Limited Pune as sales and service engineer in 1990. From 1992 to 1999, he has worked in Indian Aluminium Company Limited, that is Indal, Taloja. Later, he started his business in the year 2000 by the name Advanced Automatic Systems Private Limited to provide PLC and SCADA based automation solutions to various industries. He developed various software products under the brand of Surge SCADA Historian. He has designed and executed projects in the industrial sectors of chemical and manufacturing industry, BARC, Western Railway, ISRO, power generation and management for DG control and energy management, pharmaceutical industries like Cipla, Torrent, Dr. Reddy, Abbott Laboratory, Sun Pharmaceutical, and also few companies in China, Bangkok, Brazil, Turkey, etc., where stringent norms have to be followed. HVAC industries like Voltas, Daikin, Blue Star, etc. are also his customers. So much before the call of our Honorable Prime Minister for Make in India, Mr. Pradhan has developed this product on his own. So welcome Mr. Pradhan and over to you. Thank you.
Now we have started this company to cater the industries and provide the automation solutions to industries, and we used our expertise, hardware expertise for PLC, instrumentation, and the software. We have used branded software also. We have developed our own software and we have started catering to these industries. After providing solution to the various industries, we have encountered with pharmaceutical industries where the stringent norms are there for recording any data and monitoring the process. Where the US FDA, you must be knowing that US FDA 21 CFR Part 11 is the regulatory compliance which is required to comply for this softwares, and we're providing these solutions to various pharma industries in India and in abroad also. But conventionally, earlier we were using the controllers, indicating controllers, flow indicator totalizers, single loop controllers, and controlling the process. Earlier, the PLC was not there. So the manpower required was more, and everywhere the person are there, and therefore they are controlling the process on each loop and this thing. That's why after that the PLC came, and to monitor the data centrally, the SCADA is required. SCADA is the software where we can connect this to the PLC. It's to visualize the entire plant, including machine states, processes, and operations in a graphical environment. Is you can make your own graphics of the plant, like PNID diagram, single line diagram, and you can see the status of each machine, whether it is on or off, what is the condition of that machine. You can see that. Real-time access to key performance measures from business critical manufacturing processes. Here you can monitor the critical parameters. Some of the parameters are affecting the quality of the product during production. These are taken care by the SCADA software, which automatically rapid access to accurate information, the plant's current and past performance. Is the SCADA is you can monitor the current data, and you can access the past data, retrieve the past data very fast, and you can see in tabular format also and in trend also. Enabling the plant management to take prompt targeted corrective action whenever the plant performance drops. Here, one way is the monitoring the process. Second way is the controlling process. While controlling, you can observe and take the action whether the process or any equipment is deteriorating by observing some of the parameters, key parameters. Like a motor, you are observing a current of a motor continuously, and if the current increases, you must be seeing that you kept a threshold of high and low for the current limits, and if it is exceeding, the alarm means the motor is going something wrong in the motor. So that can be observed. Normally use SCADAs having some basic features. The graphic pages, can design the pages, authentication, alarms, events, trends, data logging, backup and restore, and reports. We'll go one by one. The graphic pages. Graphic pages is the interface for the operation of the plant. You must be knowing that the process plant is having various equipment and various pipes or machines and these things. You can make your own graphic on the pages, and you can link that graphic with the actual plant. The information on the pages either directly or by clicking on an object to reveal the information. There are you can keep various pages, and by clicking various pages, you can see the each and every part of the plant and the graphics to see the process real value. The graphics development normally are is customized. You just the symbol library is already there. You can just drag and drop the graphics and link the graphics with the tags. You'll see in the, and after the development of graphic, you can lock that graphic so that customer cannot change that graphic and can be used as a static for the customer. Normally, the graphics where some of the symbols we are used as a dynamic symbols, like a pump or a switch. As per the condition, the color of that pump can change. If it is running, it will be green. If it is stopped, then it is red. Or if it is stripped, some fault is there, you can keep dynamic color as a orange also. Authentication is the process of verifying the identity of the user. Because it's a critical process, you are able to control the process through the SCADA and hold the process. So there should be a person who is having authority to control and give the command. So every time when a user want to access that system, he has to log in as you are doing normally. And after logging username and password, he can have, as per his hierarchy, the access to the system. And if any unauthorized person is trying to access that system, it should be recorded that unauthorized person has tried to access the system, but he will not get the access. So for authentication, there is a security policy also. You can keep the username minimum length and maximum name, how many characters you want to use, the password, how many characters you want to use, that you can do. See, the password expiry date will be there. So before the expiry of the password, how many days that person, that user need to get a prompt that the password is going to expire. How many times he can, the system can accept the wrong password. If somebody forgets the password or some unauthorized person trying to get into the system, log into the system, and he's trying a wrong password. So you can set the how many wrong password, after that system will be locked. Automatic logout. Sometimes what happens, we do something changes on the system, and after that, due to some other work, we kept the system as it is. And some other person may also get the access of the system without login. So that's why automatic logout is there. You can set the logout for 2 minutes or 3 minutes. After that, it will automatically log out the system. And the passwords, what we're trying to, the password complexity is there, whether it is a numeric or symbol, or it's a combination of that, that also you can do. And what are the, how, while renewing your new password, the previous password cannot be considered as a new password. So that is also settable, that how many previous passwords we cannot use as a new password. These are the mainly authentication. The security policy is normally used in industry for authentication. Now to connect a process variable like temperature or command and these things, these pressure transmitter, then temperature transmitters are connected to the PLC, and PLC is communicating with the SCADA software. So for handshake, has been used as addresses. The PLC is providing the memory addresses, and which can be linked with the SCADA software with the dynamic tags or the graphics. So the user can configure various tags in the master by linking them with the communication address. Then the configuration of tag, there will be a different type of data types. A digital input, which is the Boolean, can be used for monitoring any status, like a pump status, like a motor status. A flow switch is there. You can get that input flow switch as a digital input. Then digital output is the command where giving command to the motor to start the motor. That can be used as a digital output. And here's the one screen I shared this one, to how to configure this one, tags, digital input and output. is the input status, is a read-only tag for a status reading. Here we are not giving any command. It's a holding register, and what will the address is the address. You can write the description of the tag and status for 0 it is on or off, and these are the list of the tags which is already entered into the system. Then second is the analog. You want to measure a continuous measurement of temperature or pressure or RPM. So any continuous signal which can be taken as an analog input, and to control a control valve is 420 milliampere we are providing to the control valve to modulate the control valve, which can be used as an analog output. And this is the screen which I shared this in for configuration of analog input. So holding register, name, you can give any name what you require. You can put the address, memory address which is required, and the description you can write. These are the tabular, in tabular format. You can see the configured tags, analog input and output tags which are configured here. Let us take one example for controlling a motor by the SCADA system or the PLC. Now, any motor starter, if you take a dual starter, there is a motor here, then overload relay is there, and contactor is there, and the breaker or a switch fuse unit is there. Is the normal conventional motor starter is there, and you want to control that motor with the PLC and the SCADA. The SCADA can give the command to the PLC, and PLC will give the command to the motor starter. To give the command to the motor to start is a digital output. Start command and stop command will be the digital output. And when you give the start, you should know that motor is started or not. You should get the feedback whether that motor is started or not. So the input status means potential free auxiliary contact you can use from the contactor as a, for a status of a motor. And second thing is if the motor trips due to overload relay or overcurrent, so that trip signal can be taken as an overload trip as a digital input. So this is a simple basic example how we can use this in PLC and normally can be configured in the PLC for a controlling purpose. This is the control circuit we have provided, and this is a single line diagram. Next is alarms. Alarms are used in a software. It triggers warning. It gives a warning when the process parameters exceeds the limit of the operation. So a process parameter which is exceeding the normal limit, it should give alarm. The user should understand that something is going wrong in the process and he should be intimated. The alarms are configured and detailed with the message, and all alarms are recorded in the chronological order and can be displayed anytime for further analysis. Here one screen I have provided is a graphic screen, and the process is running, and there is an alarm which is pop up, oil differential pressure. There is an alarm for the oil differential pressure. Here the user can see that there is something wrong in the oil differential pressure, and the oil pressure is going exceeding the limit. So you can acknowledge the alarm and analyze the alarm, and you can put that remark for the alarm. There is a on footer there is a alarm bar is there. On clicking that bar, you can get what is the current alarm, which is active alarm in the system. And here I have given that alarm summary where you can have a separate summary that which are the active alarm, which are the inactive alarms, and what are the past alarms arised in a system. It shows that messages of the alarm, when it was on, when it was off, or what was the duration for the alarm. And you can see some of the remarks are there. So the user can put the remark if something is going on. Even he can also see if any alarms are getting repeatedly. So there is a serious matter to attempt the process for a preventive maintenance action. The alarms are commonly used, and it's mainly used for the purpose of the maintenance or the process tuning purpose. The alarms can be configured in digital input also and in integer also. In digital inputs, the pressure switches and limit switches has been used for the alarms purpose also. And in analog, see if a temperature is there, you are monitoring the temperature and there is a limit high and a low limit is there. And if that, suppose the temperature you have set is 25 and your process requirement is, it should not go beyond plus or minus 5 degrees Celsius. So 20 to 30, there it is allowed, and if it is going beyond 30, it should give alarm. The alarm should be logged and recorded. Normally it is used for maintenance purpose. You can see the elaborated screen. It's a different type of alarms and how the alarm summary is being used. In the alarm summary, you can put your date and time from and to time, and you can filter the alarm, the period, the specific period, and you can see how many alarms was there, are there, and what was happening in the process. And this is the real-time graphic screen where you can get the current alarm. Okay. Let me know whether I am going very fast or should I keep the speed as it is, as you repeat.
Speed is okay, Devendra.
Speed is okay, no?
Yeah, just go more into the basics. That's all.
Yeah. Okay. Second is the events and audit trials are there. So events are it means the same that what is happening in during the process, during the operation of the process. And so every operations is happening, whether it is automatically or any operator is performing, should be recorded. So if any wall is operated, if somebody has put the system from auto to manual, if somebody put from remote to local, so all the settings, whatever they are doing, it should be recorded. These are the events. It's called events. And it's also same that you can see the events status. Status is an event also. So green is on and red is on, red is off. This you can configure as per your requirement. So these are the inputs and these are the outputs. You can get the status. And second thing, The event summary is there. You can see the past event summary. So you can see the how the process was operated and what was the sequence and who has changed the any parameters or any setting. So that can be tracked and every traceability is there to the process because it's required when something goes wrong with the product. The customer want to review the process that what was happened, why the product got damaged during production. So here he can track the events, and from that events he can understand that by mistakenly or something advertently somebody puts some control wall or a loop into the instead of auto in manual, and in manual you cannot, the PID will not work, so the output will be constant and the process goes into wrong. So these events is also required, but events, there is a difference between events and alarms. Alarms are threshold, events are the operation status. The sequence of operations can be monitored in the events. Second is the audit trial. So whatever the events, whatever the operator is doing, that are logged. So every logging will be an audit trial. The audit trial contains who has made the changes, who has operated the system, what was the old parameter, and what is the new parameter. See here, you can see here you can see the temperature set point updated from 30. Okay, here the temperature is also updated. So every maximum minimum limit change, any limit change, any read write values are changed. So everything is logged. If somebody logged in the system, that is also recorded. So who has logged into the system and why it is required. So in pharma industries, the audit trial is very key record. They need to be maintained during the audit for the audit purpose. Next is the trends. There are two type of trends in the normally SCADA purpose. Is a real-time trend which displays the current state of the parameters, and the historical trend where you can see the graphical view of a parameters of past. So you can put to and from date and you can access the data. Here's the screen which I'm sharing. This is a real-time data. You can click on any parameter which is showing on this one, and that instant real-time trend can be shown on the screen. So you can open the multiple screen to see what is happening, how the temperature is moving or the pressure is moving, and how the process works. There is a tooltip is given, so you can take a cursor on a graph and you can get the actual parameter, what was the value and what was the time at that time. So when there is a dip, when there is a peak, so why it was happening and what was the time, you can see. So during diagnostics, if something goes wrong with the product during diagnosis, the customer can see so why the temperature was deep or why the temperature was overshoot, and he can see the in audit trial or events or in alarms also the traceability, what goes wrong. So these are the statistical tools can be used to analyze the process and to control the process. Next is Next is also, this is also one of the real-time trend. Here you can use a multiple panes for a different variables. You can configure the variables as you require. You can give the color of the pen, and there are two axes, is y1 and y2 axis. So which axis you want, you can also select that axis. And here you can get the real-time data. So whatever the configured is there, that parameters, the legend will be here, and you can see the legend, and as per that legend, that you can see the graph. Here also you can take your cursor on the graph, and you can get the actual value and what was the time on that. This is also one of the important tool, mainly while tuning a PID controller or PID loop. We normally take a set point, then process value, and analog output, the output of the PID. These three parameters can be configured in the system, and we can observe that how the PI, how it is controlling the process, how it is varying with the set point, and how the PID is getting tuned. And if it is required, you can adjust the PID parameters to tune the process and get the required result. This also can be used by engineering team also and by process people also. This is a historical trend. Where you can, when it is required to access some of the parameters of the process of past, you can put a from date and to date and observe the trends of the parameters and how it was operating. These are historical trends. Now, next point is the data logging. It is normal in normal SCADA. We are observing, monitoring the status and parameters, but it is not only sufficient to observe and control any parameters. It is also required to record the data. And recording also, there is a different type of recordings are there. So the data of the process can be recorded in the system as a timestamp. Record data can be viewed in a tabular format. So you can view the log data in tabular format also. And historical trend is also one of the data logging also. And there are two types of data logging. One is the periodical data logging, and second is the event triggered data logging. In the periodical data logging, you can predefine the interval. So at what interval you need to record the data. So all the process parameters like temperature, pressure, current, and everything can be logged in the same interval. And in event triggered data logging, if you can configure the event trigger, and when that event triggers, the data should be logged. See, due to some pressure switch or a flow switch, the process, the pump trips. So that time you should know what was the parameters. So you can put the trigger on when the pressure operates, the data should be logged in this one. So that is also configured. These are the two types of data logging normally used in industry for recording purpose. Now, these are the periodical data logging, where the time interval is set for 1 minute, and you can observe the data recorded in a tabular format. So from and to date, and selecting a devices. See, you can connect multiple PLCs or multiple controllers to the SCADA system, and you can access selecting by that controller or by multiple PLCs. You can observe the data of that controller. So these are the parameters, and these are the description of the parameters, and it's being logged. So if you see the 1 minute, there is a 1 minute interval is there. Of the log data. Next important point is after logging of data, the backup and restore facility is required to protect the data. If something goes wrong with the PC or your hard disk is crashed, what you will do? The data will be lost. And most of the industries where the data loss is not accepted, and you should have a system, backup system, that it automatically take the backup of the data somewhere on different PC or on a server or on a portable hard disk, so that if something goes wrong with your own SCADA system or systems, you can take that backup, you can restore that backup, and the data can be restored and can be protected. So here, two types of backups facilities are normally provided. Backup. Here you can configure the daily, weekly, or monthly or quarterly backup. So if you configure a daily, you can give the path where you want to keep the file. So it will continuously take the backup on daily. Now when it is daily, when the date change, it will automatically take the backup and it will create a file for the backup file. This is the manual backup. Here you can manually take whenever you want. You want that, no, I want to take a backup today only. So in addition to the automatic backup, you can take the manual backup. And after taking a manual backup, you can also delete the data, because the hard disk is a constraint. If the data logged is very much and you are having some limitations in the memory of the hard disk, you can delete it. By taking a backup, you can delete the data. You can give the selection of the range. So from which date to which date you want to take a backup or delete the data, so you can be access the data. You can restore the data in the system. After installing again, you can access that file and restore that data from that. Then where the customer want to keep the records of log data or audit trial report, which I shown, an alarm and event. I'll show you again. So here you can configure use, you can add new user, you can put the expiry date, you can give them password, and while first time login, the user will change the password and he can have his own password. Second is the what I've shown you, the security policy. for any configuration of user, so what is the minimum password length, maximum password length, and prompt and dash, which I explained. So this can be done by like this. So these are the digital input tags which are configured. You can put the tag name over here. Is the status, whether it is an input status or output. So output means the command. Whether you want to give a command or you want only input. Then it is a read or read write. If it is write, then you can provide the command, or the status will be the read, and then holding register or input register or a coil. When coil means a boolean, you can configure the boolean also here. Then you can put the addresses, you can configure the address, you can give the remark description of this one, and you want to log the event, or if this input triggers, you want to log the data, is the event triggered data. That is also configured in this one. I can show you how to configure a button. So here you can have access what we have configured, the two addresses, two tags we have configured. You can have access to the tag. You can assign that tags to a button. You can give the dynamic this in color while operation of a button. Then you can change the size of the button. So this type of button also can be configured this thing. You can take a lamp also. Here we can assign for a lamp, we can assign a different color also. So this type of screen can be developed and can be provided to the customer. These are the masters. These are the utility. There is the auto backup utility, manual utilities are there. You can have a SMS facility also. These are the different screens we can provide. Then alarms, events you can see. Input output status you can see. Here you can see the current alarms. So any questions on this one? You can see this.